All right, so let's work on number 29 and 1.2. So I want to find the average rate of change of some function f of x is 3x squared plus 1 between a whole set of points, right? So between 1, 4, and 2, 13. What?
Oh, he's talking. He's looking at the f of x. He said it was another parabola.
Oh, good. That's parabola shifted up. Cool. How do I find the rate of change between a couple of points? What are they asking for here?
The slope.
Yeah, they're just asking for the slope of the line that goes through these 2 points. So on this one, it doesn't matter at all that they gave me that function, except that I might want to check and make sure that these are x f of x pairs. You guys see that? Like if they gave me an x f of x pair and another thing that wasn't an x f of x pair, I would be confused. These both are, so whatever. We'll just leave it. Okay, so how do I find the slope between these two points? What do you do? Okay, so you do change in y over change in x, and you write that as 13 minus 4 over 2 minus 1. Check, move on with your life. Okay, what do I do differently in B, where they've got j comma k and m comma n? N minus k and m minus j. Is that what you said, Ovid?
Yep.
Perfect. Cool.
How is that different?
It's not. It's exactly the same thing. Okay, so what do you do for x comma f of x and x plus h comma f of x plus h?
F of x plus h minus f of x over x plus h minus x.
Okay, and this one is only slightly different because
You have
x plus h minus x is simplifiable. So I can rewrite this as f of x plus h minus f of x over h. This thing is super duper important. Yeah, good, because I made you do this the other day. Yeah, so I'm going to throw another symbol on here, and I'm going to give you something to put on a flashcard forever. I'm just going to write LIM, and then underneath LIM I'm writing H and a little arrow to 0. Okay? This thing is the limit definition of the derivative. This is super, super crucial for calculus. Okay? And what's going on here, right, is we're taking the slope of some secant line. Right? So on this picture, that's going to look something like this. Here I've got a value x, and over here there's some x plus h. Right? And I just calculated the average rate of change between x and x plus h, right? So then what we're going to do is, in calc class, we're going to give you a way to shrink h to 0. I swear to God, it's the only new thing in calculus. There's a way to push on stuff like this. So we're going to give you a way to push h to 0. And what you're going to get, you guys see what would happen if you kind of pull this along the graph into 0?
Vertical.
Not vertical, but so like maybe here's halfway, right?
Oh.
Like there's the red line. What's this going to look like in the end? If you pull it all the way in, it's going to hit only at one point, right? So you're going to get the slope of the tangent line out of this thing. That's what a derivative does. It gives you the slopes of the tangent lines. Cool? So for right now, I want you to know that this thing is important because this is going to turn into the basis of probably half of Calc 1. Cool?
Is there an equal sign there or no?
No. So this is an operator that I'm doing to this stuff.
Okay.
So think about this thing as a function. It's not quite a function. It's a little bit more complicated. But what's up, Jim?
Isn't it when you get like acceleration and velocity, you use the derivative to find?
Good. Yeah, acceleration is the derivative of velocity. Velocity is the derivative of position. We were kind of doing that the other way yesterday, right? We were saying, okay, if we have positions and then we look at the rate of change of position, we get a velocity. If we look at the rate of change of that, we get acceleration. And so climbing down that ladder is differentiating. Cool? All right, so this little gadget is the only new thing in calculus, and if you guys are good and awesome, I'll give it to you at the end of pre-calc.